All right, and we are live.
All right, welcome everyone to our March PyData event. So today we have two speakers. So Ben is going to go shortly in 10 minutes. He's going to talk about ETL frameworks for Python, mainly Airflow and Luigi. So followed by a short Q&A session, and then after that, Sergey Karayev is going to talk about full stack deep learning, and specifically has a presentation on the topic of data management. So let me quickly introduce Ben. So Ben has, I should probably mention that both our speakers today, coincidentally, are University of Washington alumni. We were not planning for that, it just happened. Ben has spent his career focused on all forms of data. He has focused on developing algorithms to detect fraud, reduce patient readmission, and redesign insurance provider policy to help reduce the overall cost of healthcare. Also, Ben has worked with companies that range from transportation, finance, software as a service, to startups. He has helped develop end-to-end solutions that takes clients' data from raw to machine learning models and dashboards. Ben also privately consults on data science and engineering problems, both solo as well as with a company called Acheron Analytics. He has experience with hands-on technical problems, as well as helping leadership teams develop strategies to maximize their data. And Sergey, he heads artificial intelligence for STEM at a company called Turnitin, in one word. He co-founded Gradescope, an AI-assisted platform that used to grade over 1 million student exams and homeworks. He's also an instructor of full-stack deep learning, a course taught online and at universities such as University of Washington and University of California, Berkeley. And for some of you in the audience, you might actually remember that just a couple months ago, we hosted another instructor of full-stack deep learning, Josh Tobin, who gave a presentation on testing machine learning models in production. So with that introduction, Ben, you have the floor.
Awesome, great. Just see if I can figure this one out. Can I just hit present and steal it, or share?
Yeah, when you share your screen, I think Maria will put your presentation up.
Awesome. Let me know if you guys can see it.
We can see it, yeah.
Awesome. Great, perfect. First off, thank you, everyone. Thank you for whoever's joining, wherever you are, whether you are on the East Coast or West Coast. So yeah, I wanted to give a quick talk on just Airflow versus Luigi. I think these are kind of the two frameworks. When people start discussing Python ETL frameworks, they're probably the more prominent discussed ones, just because I think there are a lot of interesting design decisions that the people who've developed them have made that kind of differentiate them in a lot of ways as far as how they work and flow and how you kind of write them out. So I think that's why they're kind of commonly pitted against each other, because again, they're very different as far as how they interact. So this is a quick agenda. I wanted to cover a few points, specifically starting with why do we even use things like Airflow and Luigi? What kind of prompted someone to even develop these frameworks? Followed by, why not just build your own? Then going to kind of some introductions on like Airflow, Luigi, like what's kind of their background, what problems were they trying to solve, as well as kind of going into the different flows and how they're kind of coded. Then discuss some high-level differences, and then just do a basic setup as far as like how you would kind of set up a task in Luigi, just so that you can kind of see what it would be like if you were trying to do it on like an EC2 instance. All right, although there was kind of an intro, I'll just kind of reiterate a few things about me again. My name is Ben Rogojan. Started a consulting company, originally named it Seattle Data Guy. And from Seattle, I've been there. I grew up there until I was about 26. And at this point, if you want to find me pretty much on any social media platform, whether it be YouTube, LinkedIn, Twitter, etc., you can look up Seattle Data Guy, and that's where you will find me. Most recently, I've been doing a lot of consulting pretty broadly, working at solving a few kind of end-to-end data problems for companies, again, in like transportation, SaaS, recently a lot of e-commerce and a couple other companies as well. Originally, Seattle Data Guy was set up to be more of a data science consulting company, but it's definitely found, I think, a little bit more of a niche in data engineering, and then kind of adding data science at the end. I think that's been the most interesting kind of bit of my experience, is working through various companies and just figuring out how to kind of untangle the various messes they've had or created, or just creating an entirely new data infrastructure from scratch, and all the lessons that come along with that have really, I think, given me a pretty broad understanding as far as, like, again, ETLs and data infrastructure goes. Also, I am an accidental writer, only in terms of the fact that I started doing a lot of consulting, and as part of consulting, you do a lot of trying to market and get your opinion out there. So then I started writing, and in turn, I've also written for a broad range of companies, ranging from like Fivetran to Rockset and a couple other companies. So that's just a little bit about me, kind of what I do as far as in the data space. All right, so first off, to start out with, why do we use tools like Airflow and Luigi? I really just kind of group that all into process automation. I think a lot of people kind of focus on things like Airflow and Luigi, mostly for ETLs or ELTs, which dumbed down really is just about getting data from point A to point B. But I think I've also seen, Airflow be used for just about anything, or specifically Airflow, but also Luigi, for any form of like workflow management. Really, these tools can manage things like batch ML jobs, or just general automation. If you have some sort of process that you need to have happen in certain steps, it doesn't necessarily need to be a data job. It could just be some sort of process that needs to happen, in some sort of order in ABC. I think it's generally helpful to have tools like Airflow and Luigi, because they manage a lot of things that you might not be thinking of when you first start out on your automation journey. Just to kind of cover like that in terms of why not just code it yourself. Just from the perspective of someone who's come in to a lot of various people's kind of ETL frameworks and infrastructure, oftentimes what I'll end up finding is, again, you've got all of these data sources, and you'll have this weird combination of, cron, Python, PowerShell, some Excel files, some config files, and really just a mess of other things that try to talk to each other, try to manage each other one way or another. And you end up having this major problem where, again, it's just very difficult to manage anything beyond a few data pipelines. And especially as companies are kind of growing in the whole space of whether it be ELT or ETL and trying to process more data, trying to essentially manually manage all of these automated processes becomes unwieldy and borderline impossible. Just because, again, trying to run cron and just guess what time a task will end, and then assign the next task to run, whatever dependent task that might be, at a few hours later, doesn't scale well, and it also misses a lot of areas, such as if there's a failure, logging, and a couple just other things. So generally, what ends up happening is, again, either someone ends up developing a bit of spaghetti for their ETL code, or they end up essentially just redeveloping Airflow or Luigi or something similar by developing their own ETL framework with its own database, with its own kind of dependency management system. And so that's kind of the main problem we end up running into. Really what we're trying to solve and trying to create is kind of the classic, I'm going to say the classic solution is the ETL. I would say a lot of companies are definitely looking at ELTs too. Also, I didn't really define ETL. So for those who maybe aren't as fresh with that term, it just means extract, transform, load. And ELT is just a different version in terms of you've now moved the load to right after the extract, and the transformation after that as well. So both of these basically just try to perform a set of tasks in a certain order. So you can kind of see just here this basic diagram. Instead of having kind of a cluster, you generally want to have very defined tasks that have defined order of operations and some sort of dependency management system. So that's kind of where we're going, or that's kind of what drove a lot of people to essentially develop things like Airflow and Luigi, is just to have something where you can easily kind of point out what task belongs to what task, depends on what task, and what's the general flow as far as what the direction goes. This is often referred to, like what you see up front here, this kind of like task A, task C, task B, and then so on, as a DAG. So DAGs just stand for Directed Acyclic Graph, and just kind of manage that whole process. So just kind of comparing Airflow and Luigi, they're really two tools that I feel like were developed in similar timeframes, or at least during similar times. Airflow around 2014, Spotify I think was like Luigi around 2012. Both by companies that were trying to figure out how to better manage their data. One being Airbnb for Airflow, and Spotify and Luigi. Really, both of these tools, again, were kind of developed with the similar goal in mind, which was just better workflow management. Luigi kind of, I think, whenever it's discussed, it is focused a lot around Hadoop and Hadoop jobs, although it has definitely grown substantially since then. And you can pretty much use it towards any task you're trying to manage. And similarly, Airflow, I think, has grown a lot in maturity as far as the different sources you can work with, the different tools you can kind of work with, and it's definitely broadened out. As far as if you were to look at these two, and we'll kind of dive into this later on, if you were to look at these two and how they were structured, Airflow, I like to state, is more of a configuration code style, whereas Luigi fits in a little more of like a code heavy or code focused style. And I'll kind of go into this more, but what you'll see is that Airflow tends to allow you to set parameters a lot, and really just call what we call operators. And then just give it certain configurations, whereas Luigi tends to be a little more flexible, and you can kind of code very specific tasks. And again, I'll kind of break down those things here shortly, but it's a little bit more towards the code side. So that's kind of like the high level, if we were to look at the differences between Airflow and Luigi. That's generally what separates these two kind of libraries. So if we were to look at things from like a high level, and the things that make, I think, Airflow unique, and the things that you don't want to have to code yourself, and you'll find coding yourself if you end up developing it, is Airflow has a couple components. So for example, it has the scheduler. That just basically helps manage when jobs run. This is kind of like, again, similar to people trying to manage things in cron. Instead of having to sit there and code all of your things into cron, you're able to tell your Airflow DAG when it should run. And that's usually set up in the DAG code itself, which is also great because then you can store it, as you're coding and to Git and make sure you've got that version control. It's not like something you've got to go in and manually manage on the specific Linux box that you're running. Similarly, it also has dependency management, which is one of those, I think, major benefits as far as trying to manage tasks. If you've ever tried to build an ETL without some sort of dependency management system, you got to play this game of trying to make sure you run tasks in the correct order, because you don't want to have an empty table, you don't want to have a file that doesn't exist. So having some sort of dependency management system ends up just being a benefit, and really that's mostly managed in each kind of script. They each kind of allow you to basically delineate which tasks should depend on which tasks, and you can also end up basically putting dependencies on specific external tasks as well. So if you've got multiple DAGs, you also have the ability to manage the dependencies of not just that current DAG, but also tie it to other DAGs. DAGs just being essentially a group of tasks. Another kind of major benefit is the metadata database. So that basically just tracks a lot of the various objects and like tasks and DAGs, as well as a bunch of other objects that exist kind of in your Airflow code. Again, helping to manage things like historical performance, as well as kind of dependency management as things grow. And this is really what I think allows you to scale out as you keep building, because it's kind of one central place that you can manage everything. Next is the actual executor itself. So along with the scheduler, you need something that actually executes the code, and you need to kind of give it how it's going to execute it. in terms of, is it going to be able to distribute the jobs? If you're running like multiple jobs all in one box, can it distribute it? Can it not? Does it have to run everything just sequentially, basically one pipeline at a time? And that's basically what the executor does. And I realize I spelled executor wrong, just looking at it here. But yeah, that's essentially what the executor does. Another popular one that's not listed here is the Celery executor, because it allows for things like distributed execution of jobs and having a little bit more, just allowing you to actually manage a lot more big data and multiple tasks at one time. All right, so if you're to break down kind of the key concepts as far as like what you should know as you're building out your various kind of components and various DAGs, again, in Airflow, starting with it, again, I've covered the concept of DAGs, but just going into, again, understanding that that's kind of one unit of work in terms of it's going to have lots of little tasks inside of it, inside each DAG. And then those tasks are usually built off of what we call operators. So operators essentially act as some sort of specific utility. So it could be specifically you want to create some sort of task that interacts with Python, or maybe it interacts with a big table or some sort of AWS component like S3. These various operators are kind of like, if you've used like SSIS, kind of like those boxes you used to drag as individual components that would only interact with like one thing. Like maybe one of those boxes only interacted with Oracle or SQL Server. And then from there, you would just configure it to the Oracle instance or the SQL Server. And then you put some sort of SQL query you wanted to run into it. And you just basically fill out those parameters. That's kind of the same way an operator works. It's really just a very defined wrapper of code that runs a very specific, basically against a very specific type of other component, again, Python, big table, etc. You can take those operators and then essentially create tasks. Those tasks are just more defined, or just a defined operator, so it actually does a specific thing, and then those tasks build up DAGs. So that's kind of the buildup of your basic DAG in Airflow. Along with that, you have some other components, including sensors. So sensors are really useful in terms of if you've got external tasks that you're trying to keep track of, or maybe external files that you're waiting for. A sensor can essentially track to see if that file lands or if a task finishes. So if you've got external dependencies, this is a major benefit of what a sensor can do. It can just help track all of those various external dependencies. Hooks essentially act as an interface for other systems. So you could basically have an interface with a Hadoop system and then just store all of your credentials into that specific hooks information, and then just reference it later on, whether that be in a Python operator or some other operator. And then XComs kind of allow you to pass data in between each task. So the thing about each task is, for the most part, they are isolated. So they don't really discuss anything with each other. It's not like a function where you can return something back. So if you want to like maybe get some variables in return, or if you want to get a list of something in return, you're likely not to get that from a task. One way you can try to start getting around that is XComs. That gives you some ability to actually pass some information around and utilize it more dynamically. So you're not too tied to tasks. There's also something called variables, which has some similar connotation, except for variables are more meant to just be kind of global bits of information. And so it's a little slightly different, because an XCOM can actually come from another task. All right, so if you were to kind of just give a high level of what an Airflow DAG would look like, you could have, again, some sort of file that you could be waiting for, and you could have a file sensor that is waiting for it. And just configure that file sensor to or task A, in this case, to be dependent on that file sensor. So if that DAG is set to run at 12 midnight, but only if file A exists, then it'll just wait. That file sensor will just wait until that file shows up, and then it will start running the rest of the DAG. Similarly, with DAG B there, maybe you've got a task sensor where it's specifically waiting for a certain task ID to finish. And once that task ID finishes, then it will kind of kick off the rest of the tasks. And so this lets you kind of get that benefit of not having to sit there with cron and guess what time something's going to run, or when a certain file is going to exist, or maybe have something that keeps rechecking an SFTP or something. The file sensor will do that for you. So it takes away a lot of the heavy coding and abstracts a lot of what we do as data engineers away from like custom coding and more into kind of very parameterized blocks of tasks. In the end, that really saves, I think, a lot of time as well as future maintenance. And so that's why I think I still rely heavily, I think, on Airflow. Although there's, again, you can kind of switch between Airflow and Luigi. I think personally, I've always leaned towards Airflow. So some key concepts, if we were to then like look on the other side for Luigi, is the fact that it's got what is called a central scheduler, and it also has something that's a little more experimental, which is its task history DB. So the central scheduler is slightly different here. Unlike Airflow, that has a scheduler that essentially manages all of your jobs every day and is running every day to just, or you can set it to run essentially as a process underneath and just check and manage your whole system. The central scheduler is running underneath, but you pretty much need to kick off the jobs or have some sort of cron job set up to kick off some sort of job. The reason being essentially Luigi is set up to be more of a task management system. So you can manage tasks in a specific order, but you still have to have something to kick it off. Really, all the central scheduler does is make sure that two instances of the same task aren't running, and it gives you some sort of visualization if you're running like a long task. This is kind of very different than Airflow, again, where Airflow does a lot of this management for you. You're not going to have to sit there and manage some sort of cron scheduler, because generally what I think I've ended up seeing people do in these cases, if they use Luigi, is they essentially have to develop their own version of Airflow scheduler if they really want to scale out their system, just because of kind of the limitations of scheduler for Luigi. So Luigi is definitely a little more of a simplified, I'd say, task scheduler. There's really two main components that I usually think about when you're kind of doing your work. You've got tasks and targets. Really, the tasks usually produce some sort of output file, which is some sort of target, or maybe you're waiting for some sort of target. It could go kind of either way. You're either waiting for an input or you're waiting for an output. And that's kind of the thing that you're requiring typically to occur. So there is still some ability to set some sort of dependency, but I think it's a little more limited than Airflow. So if you're to look at kind of just Luigi and like a basic set of tasks, you would, again, still have like a task A, task B. And each task, instead of acting as a like wrapper, you've got more of a defined class here. And each of those defined classes have methods. In particular, it's got a requires, or you can essentially invoke a requires, a run, and an output. That output essentially being usually a file, but the run being the main thing that you're actually trying to do. The one nice thing here is with that run, it is more like a function. So you can kind of call whatever you want underneath that. So you can do whatever work you're trying to do, produce some sort of output, and define that output, and then it's basically going to run. And then you can set some sort of requires to basically say, hey, wait for the previous task in the next task. And so that kind of gives you, I think, a little more flexibility, but definitely doesn't offer as much structure and infrastructure if you're trying to scale out your product and really build a more massive ETL kind of framework for your company. I'm going to go into Luigi just slightly later, but I felt I would just kind of look at Airflow and Luigi code kind of side by side. So this is going to be a very similar task that we're trying to do in both. What you'll notice in the Airflow task is you've got a decent amount of just setup. So you've got everything from some default arguments that just allow you to set who to email if there's a failure, when to start running it, who owns it, and a lot of other just metadata that can be very helpful if once you start scaling out your system, just because it, again, lets you manage things like failures and as well as notifications much more easily, as it's just kind of developed in the system. And then you've got, besides the default args, the DAG itself, so the definition in terms of like name, but also the schedule interval. So this is where or the schedule interval is what basically allows you to avoid having to utilize something like cron, since it will basically work as cron for you. And it will essentially abstract that away for you, since you can just set it up in the code rather than having to set it up externally. Again, this just makes it easier to manage and do future work. And then from there, you'll kind of see where you've got that bash operator and the Python operator. So those are the tasks essentially where you see T1 and T2. And you can define, again, those parameters. And as you can see, you're not really necessarily coding very heavily. Besides that custom Python operator, it's not code heavy, but instead it's very parameter focused. You're really more just trying to define certain things and certain concepts in there, but you're not as interested about doing a lot of custom coding. And then the very bottom there, you'll just see that essentially the path that the tasks take. So it starts with T1 and then runs T2. So that's kind of its simplified version of dependency management. And then to compare like similar workflow in Luigi, you've got kind of this similar or a much shorter code, because actually you didn't even see the import statement in the previous one, which was also like 4 or 5 lines. But Luigi kind of breaks this down and makes it much simpler as far as the process goes. And as you can see, you've kind of got some very clearly defined methods that each task will call. Again, you've got the output, the run, and requires. And this kind of really breaks it down and makes it simple to, I think, understand. Since all you need to really understand is what's the code you're going to run, and essentially that's like the main goal of the task. What does it require in terms of what are the external tasks that maybe it depends upon, or in this case, we've got this write a file task, which is the task above, so it depends on the previous task. And then it's got some sort of output. So in this case, it could be a file. It could also be inserting into a database. It's pretty broad as far as what you could put as the output. But overall, again, I think if you just comparing these two, one is more focused on being configuration heavy. So it's very beneficial, I think, as you start writing more code. I think you start benefiting from that. But when you're doing simpler tasks, I think you've got a lot shorter or a lot less code to write, and I think a little more intuitive code to understand with Luigi. And I was also going to say, so there have been a few changes as far as Airflow 2.0. So Airflow earlier this year has basically come out with 2.0, and there's been a lot of different things that have been improved. Honestly, I've only covered 3 here. So they've, for example, improved the scheduler. Basically, before it was very difficult to run like multiple schedulers, and scaling was very difficult. But now they've basically kind of improved the scheduler to increase or reduce, have low latency and kind of allow for more horizontal scaling. So that's been a benefit for people who have probably been trying to work around a lot of Airflow's limitations. Similarly, the full REST API kind of before was more experimental, so you were kind of limited on how much you could actually interact with and integrate with Airflow and its database. And now we've kind of gotten to the point where it's not just an experimental API, but we've got a fully kind of managed API that lets you kind of deal with different CRUD operations there and some smart sensors. I think Astronomer has the best article as far as covering all these different benefits that Airflow 2.0 has provided over the last, or as recently kind of put in place. I think people are still trying to figure out if they actually benefit them or not, as people are kind of testing this out and working with the different kind of, the different benefits. Okay, so just kind of comparing things more head to head, if you were to just look at things and trying to figure out, which one works best for what tool, and maybe which one you want to use. So just looking at the two, as far as usability goes, I think Airflow overall can tend to have a little bit of a longer learning curve. There's just a lot of different components, from operators to sensors to hooks, and it can take people a little bit longer as far as just getting comfortable and feeling like they understand Airflow. Also, in order to kind of get a lot of the benefits from Airflow, as far as scalability and things like that, you are going to have to do a lot of configuration. The base kind of functionality of Airflow, it uses things like SQLite and just basically the sequential executor, which might not be what will be best for you if you're trying to scale into more distributed processing. So you're going to have to spend some time as far as managing the different configurations. Luigi, I think overall is much more straightforward. Personally, it's just very easy to get started with. You don't have all of these operators that you have to learn or figure out if they exist. You don't have to create custom operators if you want to have new tasks. So there's a lot of benefits there as far as it's very, very, very fast in terms of becoming comfortable. Also, in terms of configuration, it doesn't offer, I think, the same ability to scale, but at the same time, it also doesn't require a lot of configuration, and it's very lightweight and very easy, I think, to implement for anyone who's just familiar with Python in general. There's no nuances or extra steps you're gonna have to spend just to learn how to, again, connect to a database or do some of the best practices with Airflow. Okay, so just kind of reiterating on scalability, I think Airflow really was built personally to scale. Everything's from the fact that it has different kinds of executors that allow you to take on the ability to manage and map multiple jobs, compared to Luigi, which really still relies on cron. And if you want to scale, if you want to do anything that scales to any degree, you're going to have to spend some time either developing it yourself or custom coding it. I think I might have seen 1 or 2 solutions that will do that for you, but overall, you're going to have to spend a lot of time just trying to work with and further kind of develop Luigi's current capabilities. I also think logging is kind of an issue when it comes to Luigi. Like, it does allow you to log and track like you normally would, but overall, I think Airflow has really developed a more robust logging system as far as like finding files and tracking down what's occurred. I think Airflow has really done a much better job as far as what it has and what it offers, including in its UI, where it just makes it very easy to track down various logs. So if something fails, if you have some sort of mistake, it's really easy to just see from the beginning, and you're not kind of stuck wondering what went wrong. So you can not only track some of your own custom logging like you normally would with like logging.info, but it does a lot of its own logging as far as tracking what jobs went, what task failed. And it's, I think, personally, one of the big standouts as far as one of the reasons I lean towards Airflow a lot. So just looking at the UI as well, I was going to show Airflow, but I'm just going to be stuck with Luigi just because of some current issues with my Airflow that set up. Overall, I think Airflow does provide a lot more in terms of information, like when things fail. It was also, again, built to allow you to run it every day. So you will find that when you're running Airflow, you can actually look back in history and see what task has failed in the past, how often it's failed. You can also look back at old logs. You can stop jobs, start jobs, and as well as like pause certain jobs. And so that all of those different kind of steps, I think, provide a lot more information. And overall, I think just give you a clearer picture on what's running and how often it's running and how successful those jobs are, which when you're talking about more maintainable systems, I think is kind of an important thing to point out. Luigi, I think for the most part, their UI works fine, but most of it's focused on just that current task. Once you've kind of finished running a task, it will eventually go away from your UI because it's really just that, again, it's more of a task manager in terms of it's going to run your whatever pipeline or automated task, and then once it's done, it will give you a little information about it. But overall, it's really just built for the current task, and not the central schedulers kind of limits some things. So I was going to do a quick demo, and then we can probably do more of a QA. I'm just curious what time it was. So I'm just going to kind of walk through a basic example of, let's see. I was trying to see why my Airflow wasn't working, but it was being funky. Can everyone still see my screen? Hello?
Yes, but if you could make it a little bit bigger, that would be great. That the
Bigger.
font is a little
Oh,
too hard
no.
to read.
I don't know how to zoom. Wait, is there a way to? That's gonna be so.
That's a good question. How to zoom
bigger?
in terminal? I'm not sure.
No, I've never thought about a default font size. No.
Control plus, maybe.
Okay,
It
interesting.
works. Yeah.
I've never done that. Okay. All right. So I just wanted to do kind of just show an example of some pipeline and how you might run it, and then also some things you might run into while you are running your pipeline. So let's see. I think it was in the example. Oh, nope, I was wrong. All right, I'll list. Oh, sorry. Hold on. All right, so I just want to kind of cover just a basic example. This is kind of still the same example that I covered earlier. Again, you've got your, in this case, 2 tasks. One is just going to print out to a file, hello world. You could really define that as anything as far as, if you wanted to do something more like inserting into a database or extracting data from an API, that could just as easily go there. That will then just into my local file, it will just deposit hello world txt, and then later on the next task, which is waiting for a hello file task, will run and count essentially the various spaces or the various characters in that output file. So, oh, come on. Oh no, actually caps locked. Sorry. So in order to kind of just set this up, I'm just gonna hit up. Where'd it go? Oh, there we go. So you should see, like, this is essentially me just calling the basic task in Luigi. I'm not calling it with local scheduler, which is an extra thing you can add. So I'm just calling that count task. So if I were to run this, it will essentially, if it ran successfully, tell you that it ran those 2 tasks. And if you want to see it, oh, hold on. If you want to see it, you can essentially visualize it here in Luigi. I've just got this running on EC2, so that's why it's just set up here at my EC2 instance. You'll see that both these tasks have run, and if you want to kind of see back into like kind of the history and what it depends on, you can see the actual process that it goes through. That hello file task, and then the count task follows afterwards, and green basically meaning that both have run. So that's kind of the basic of how that would look like if you're trying to see if your tasks had succeeded. The other thing that I will point out is that if you were to try to run this again, you'll notice that only 1 task ends up running. This is because it's essentially waiting not for the task to run, but more for the output to exist. So in this case, the file already exists, so it's not really going to wait for another file because it's already like that file exists. So I only need to run the count tasks. So that's just, I think, an important thing to point out. If you're confused, if you've happened to be working with Luigi and you're wondering why your second task isn't running, all you would have to do is really, in this case, I've got it running remove data. And if I rerun this, you'll see that both tasks have run again. So that's just how it's set up in terms of the fact that the count task is really waiting for the file and the output more than it's waiting for the actual previous task of that output. I think I'm done much earlier than I had hoped. So I'm sorry, I think I finished a little earlier than I'd hoped, but because I also started 5 minutes early, so it would have been 10 minutes early. I don't know if anyone at this point has any specific questions on maybe Luigi and Airflow that I can maybe help provide some sort of insight into.
Yeah, Ben, there's a couple of questions from the audience, as well as I have a few. So first question from the audience. Have you or do you use Airflow for logging, for monitoring machine learning?
So when you say logging, do you I hope someone can provide more information or context. Do you specifically mean like the output of machine learning, or do you mean for just managing machine learning pipelines?
Let's try and address both, I guess.
Yeah, so I currently do have a project where I do some NLP processing through Airflow. So it just runs kind of every night over kind of new files and PDFs that were created. So I use it from that regard. Logging, not as much. Like I have systems to log kind of the output, and most of the logging I do for like ML is generally trying to see kind of, how did people respond to like recommendation systems that I currently have in place for a couple of customers. Are they actually, if I change that model, does it improve the respond rate? So that's generally the stuff that I monitor. I don't necessarily have a pipeline for that. I mean, I've got some clickstream, I guess, pipelines, but it's more of, I think, I already had that pipeline set up, and it wasn't specifically for the ML. It was already just tracking a lot of the website usage. And then the ML just acts as kind of the fact that I've implemented the ML just kind of works really well there. I don't know if that makes sense.
Okay, and somewhat related to this is, so another question is, where does Kubeflow fit in all of this? And like, when does it make sense to use both?
Yeah, I'm not like fully familiar, honestly, with Kubeflow. Like I just haven't had to integrate or work with it as much for a lot of my clients, just because I think I've had a lot simpler ML flows overall. That's definitely kind of been my current, I think, one of my learning projects for this year. So I haven't had to actually integrate it that much. So I don't know if I'd be the best person to answer that.
We actually got a clarification from Peter regarding the first question. So monitoring machine learning models. So he refers to monitoring outputs, assessing drift. So here I mean data drift, and triggering based on that. And again, I'm speculating here, but I'm assuming it's triggering events like maybe retraining your model if there's a data drift.
Sure. I think overall, currently, just because like most of the models that I've been working with haven't had to have been more numeric, but have been more like, again, like NLP. I guess I haven't seen any issues just yet. So I think maybe that's something I might have to put into play. But overall, I think they've been recommending fine. So yeah, I guess I haven't had to do that much.
Okay. So another question is, how do you choose the machine nodes to run Airflow in?
I'm curious what that means, I guess. Like, do you mean in terms of where I'm operating it? Like if I'm using like a Docker image, or if I'm just, because like generally like what I've set up things is just an Airflow and Docker on like an EC2 instance. And that's generally what I've run off of. I don't know if there's something more specific that I'm missing off of that question.
I guess part of the question is in terms of, that's, so there's a clarification that came in, is in terms of the resource management side. So let's say if you're using Airflow to manage workflows that are spread out across multiple machines.
I guess I haven't had to manage more than like one machine at this point. So I haven't had the benefit or had to suffer from figuring out celery just yet.
Okay. And I guess I have a question about, so like from the general impression that I gathered is from your presentations that Airflow, while it has maybe a steeper learning curve, it's more customizable. Like you mentioned a couple of times that you do prefer it over Luigi. So I guess the question for you, what are other use cases, even if you can think of hypothetical ones, where like you would personally go with Luigi instead of Airflow? And can you describe some of those use cases?
Sure, I can see if I can come up with something that makes sense. I think overall, like I actually think that like Luigi is arguably more customizable, only in the sense that it's a little more code focused. So I do a lot of work as far as like in Airflow and similar things in a similar library that is also very configure heavy. Like it's very much more focused on configuration and a lot less focused on kind of the code. So in general, I find that that's a little more limiting. Yes, you can write a Python operator, but at a certain point, I think the goal of Airflow is to kind of interact more with the data sources and less custom, like less on the custom side. so I think for Luigi, where I usually see that maybe it fits is if you've got really lightweight kind of work. If you don't have, if the company's not going to have a huge workload in terms of like how much you have to scrape, because again, you're just going to have to spend a lot of time managing it. And I think that's the big difference in why I usually lean towards Airflow, is just because it's the amount of time that I'm going to have to spend managing and actually maintaining code versus just building a pipeline, letting it run, and then letting it tell me when something goes wrong, and not having to create anything around it that will basically help do the management. Because I've seen people kind of develop some custom stuff around Luigi to help manage it, but then I feel like you're having to write it yourself. So unless you feel like Airflow is too restraining, which is I think the one place that maybe Luigi could be better. It's like if you feel like it's just too restraining for what you're trying to do. Yeah, that's why I usually lean towards Airflow. I don't know if there's one place I prefer using Luigi. I'm sure there are some people who like it, again, because it's a little more customizable, but yeah, for the most part, I've gotten away with Airflow for a long time at this point.
Okay, so we'll have more questions from the audience. So as a consultant, do you find yourself composing DAGs around existing systems and dealing with how the company currently has things set up?
Yeah, it's a combination of both. Like I've had the opportunity to luckily come in and just do kind of a green field kind of work. So, just come in and define things myself. So, I can pretty much just come in and say like, okay, well, you have nothing, so I can build this off Airflow, and, can use something like, maybe you're on AWS and that's my one limitation. There have been some cases where you're having to either work around or kind of deconstruct what they already have. So maybe they've already got some bash scripts in place that they're operating, and you have to either recode it or kind of like pull an Indiana Jones and migrate away from those kind of situations. You also, I think the other thing that I've been running into is there's a lot of companies out there that have varying levels of technologies. So I've got one company I work with where they've developed all their technology. It's been around for 20 years. It's all custom code. So you're having to interact with, something that's not documented, and you're kind of peeling apart the layers and understanding the data for the first time, essentially. Like they've only understand it from an application side, and you're having to kind of parse all the logs, parse all the use kind of clicks themselves, and actually make sense of it. And then you've got a lot of other companies that are using things like modern ERPs, which have personally been very helpful, because at this point I've got a few tools as far as like abstracted away API request tools that just pull all that information pretty easily. You also, at this point, I think, have plenty of ETL low-code, no-code solutions that you can also pull from. But I haven't dabbled as much in those. So I think hopefully that answered your question. I think I might have gone on a little tangent there, but hopefully that answered your question.
Okay, thank you. And I think we are ready for next speaker, Sergey. Thank you, Ben.
Yep. I'm trying to stop. How do I stop sharing? Did I stop sharing?
I think you've stopped. Okay. I'm on.
Yep. Feel free to share your presentation, and yeah, the floor is yours.
Well, thanks for having me. Thank you, Ben, for the first presentation. Quite excellent. And okay, now to figure out how to share. Share screen. This works?
Yep, we can see it.
Okay, well, thank you for your attention again. Briefly about me, I work at a company called Turnitin. It's a big ed tech company, and we have 35 million students served. It's originality checking, but also grading. There's been over 1 billion submissions of different essays to the service. I got to Turnitin because a company I founded was acquired by them, and that company is Gradescope. It used to be a TA side project, and at Berkeley, and we built it kind of for our own use as TAs. And since then, it became a pretty widely used thing. There were 80 million student answers graded by over 10,000 different instructors at the time of the acquisition, and it's really grown in this past COVID year. That's crazy. I've also organized this full stack deep learning course. I'll talk more about that on the next slide. And then I went to Berkeley and University of Washington. So I'm also in Seattle. Full stack deep learning is a program that started as a boot camp, like an in-person weekend boot camp for around 150 people that basically addressed what we saw as a gap in the education space, which is there's great courses for deep learning theory and training deep learning models, in a notebook environment, but no great course really covered what to do after that. Like, how do you actually ship the whole project, or how do you even start the project if the data set's not already available, and so on. We have a website. We're actually teaching the course at Berkeley right now and posting all the lectures publicly. So give us a follow on Twitter if you want to get the updates. And can someone say something so that I know my new speaker configuration works?
It works. We can hear you perfectly.
Perfect. So just as a little motivation, this is the lesson about data management. There's an observation on Twitter that people aren't that interested in building data sets when they start out in data science or machine learning. They're more interested in training the model, but the data is actually like half the problem or maybe even more. And in fact, if you survey practicing data scientists, they say they spend most of their time on data. And in fact, processing data and doing stuff with data can actually be the most difficult part of the project in terms of optimization or even just how to do it. And the reason, I think, is because there's a diversity of approaches, right? So for deep learning specifically, we have data sources. Maybe they're images on S3. Maybe it's a bunch of text files just on a file system. Maybe it's log files on some server, or maybe it's database records. But at some point, we're going to need to get them over to a machine with a GPU, specifically for deep learning, right? Which is what this course is about. And at that time, the data lives on the local file system, real close to a GPU, so that we can load the data efficiently onto it. But in between, there's a different path for basically every project and certainly every company as to how to get the sources to the training time. Now, maybe you're training on like ImageNet, so you just have a nice file that says like, here are the image URLs, and all you have to do is just download them. But maybe you have a text corpus that you first need to process with, let's say, Apache Spark, and then maybe you select a subset of it with pandas, and then only then can you train deep learning. Or maybe you're doing something like what Ben was talking about, and using something like Snowflake, or in pre-processing data from different sources into a data lake like Snowflake, and then from that outputting something that can be trained on. So there's really countless possibilities. And the rest of the lecture is going to be about those possibilities. But before we get started with that, just some key points. Let the data flow through you, right? Spend 10 times as much data, or spend 10 times as much time exploring the data as you would like to, right? It should feel uncomfortable with how long you're spending just looking at the data and not training, because it really would pay off. Adding and augmenting data is the best way to improve performance most of the time, instead of improving your model. And also, there's a proliferation of tools and approaches, but it's usually worth just keeping it simple as far as we can. So when we look at data, there's a lot of items in the ecosystem, and we'll go through them in sequence, more or less. I'll probably go pretty fast, and I will stop for questions in between, like after every section. So please type out the questions as you get them, or thoughts or reactions. If I'm saying something you disagree with, that would be great to hear also. So for sources, well, for deep learning, you usually need lots of proprietary data. And there's exceptions to that, like reinforcement learning, or maybe GANs, which are very data efficient, or stuff like GPT-3, where the data is not necessarily proprietary, but it's so large and the model is so large that the proprietary part is the fact that you can train on the data at all, not how you got the data. But for basically everything else, if you're using publicly available data sets, that basically means you have no competitive advantage, because someone else can come along, apply the same type of model to the same data, and be roughly where you ended up. But it's definitely useful because it's a starting point for for your project, right? You almost always start with some publicly available data. And then you would usually spend, dollars and time to label your own data that no one else has. So here's like satellite imagery that you might be labeling. And it's kind of a shame, but many different companies are going to spend, money labeling the same data, just in maybe slightly different ways. So if you're a hedge fund, maybe you're trying to track the flow of traffic to shopping malls or something. Or maybe you're a nonprofit, you're trying to track deforestation or something else, but you're labeling the same type of data, just in different ways. If you're working on a product where potentially your users can contribute trainable data for you, then that can enable really rapid improvement. So Google Photos is a great example of a data flywheel like this, where they ask you, did they get their prediction right? And I, as a user, am incentivized to answer, and then it benefits them when I do answer. And then recently, there's an explosion of work about self-supervised learning, where you use the data itself to provide the label for other parts of the data, right? So for example, you can take a sentence and just blank out the last word. And so all of the sentence up until the last word is kind of your training data input. And then the word that you blanked out is the label. And you can do that not only for the last word, but for any word in the sentence. Or you can take two sentences and ask, did they come from the same paragraph? Or you can take two paragraphs and ask if they came from the same article, and so on. So you can use the data itself to provide labels for other parts of itself. And you can do that in vision also. For example, you can take two patches from a photograph and simply ask, is patch B to the left or to the right of patch A in the original image? And this is a very important idea that just recently, this month, Facebook posted a work called Seer, which basically trained on 1 billion random unlabeled images. And achieved state-of-the-art accuracy on a labeled data set prediction task. So they trained without any ImageNet labels, but they achieved best accuracy on ImageNet predicting the labels. And the way they did that is with some novel loss functions and data augmentation techniques that they actually open sourced in this library for self-supervised learning called Vissel. So it's well worth a look. I mentioned data augmentation just now, and that's the idea of basically something you must do for training vision models, and all the frameworks provide functions to do it. The basic idea is like take your training example and change it in some way. For example, flip it horizontally, like a mirror image. And the label doesn't change from that, right? But the model gets more useful information about the way the things look in the world. You can rotate, you can change the brightness and contrast, you can take random crops of the image and all of these things, or you can take crops out of the image where like some of the image data is now gone. And all of these things are incredibly helpful to achieving high performance. And this can also be applied to other data. Like if you have tabular data, you can blank out some cells, and that might simulate the situations where you might be missing data. In text, I'm not aware of like really good techniques, so maybe I'll just skip that. But in speech or video, you can certainly do some stuff. So for speech, for example, you can crop out little portions of the WAV file. You can shrink or stretch, thereby changing the speed of the file. You can inject different noise. You can mess with the frequency. You can like blank out certain parts of the frequency spectrum. You can start with synthetic data, which is a pretty interesting way to start because you can gradually ramp up the difficulty of your problem. So here's an example from Dropbox that hold on. My dog is just playing with stuff in the room. They used synthetic generation of word images to train their OCR system at Dropbox. And this can actually get pretty deep. Like here's an open source project that is for receipt text recognition. And they actually used, I think, the Unreal Engine to deform the receipt model in like really realistic ways and really complicated ways. But they knew exactly where each character that was printed on the receipt ended up because they knew the deformation mesh, and they knew like they can mess with the lighting and the camera properties because it's a 3D engine. And this is often used in self-driving cars and robotics applications. Does anyone have any questions or reactions?
Yeah, so I was wondering if any data, like I've seen some data augmentation techniques for NLP, and I'm wondering what's your opinion on that. For example, if we have a limited set of text data, what if we use some other like language translation model? Let's say we translate from English to French and then from French back to English. And most likely we're going to get the sentence that means the same thing, but maybe doesn't use exactly the same words or exactly in the same order. Maybe there are some synonyms in that. What do you think about techniques like that?
Yeah, I'm not an expert in NLP. I'm not sure. I'm not really sure. My hunch is that it wouldn't really work that well because I think the quality of the translated text is still not that great, especially if you translate back and forth. You start getting stuff that doesn't really sound like actual English language. And if you have some heuristic where, like, for example, you switch out synonyms with their synonyms, I just don't know. I think in text, self-supervised learning is a much bigger idea because there's so much text out there that you can train huge models like GPT-3 just on the prediction task, right? You give it a few words and then you predict the next word, and that tends to be like the most effective thing you can do. So maybe there's just not as much need for data augmentation in NLP. But I'm curious if other people have knowledge of things that do work.
And I know if you have experience in other domains, but can you give examples from, I know, if we need to augment time series data set or a video sequence data set? Are there any examples that have worked in practice that you observed?
Well, for video, like all the same stuff you can do with images applies. You just apply it to each frame. But in addition, you can then shrink or stretch the video, right? You can drop frames to kind of speed the video up, or you can interpolate between frames to kind of stretch the video out. I think that's really, yeah, okay. I think that would be it. Maybe like, yeah, I think that's what. For medical type data, like volumetric images, I don't know at all. I'm not totally sure. There must be some augmentations you can do, but I haven't worked in that domain.
Okay. Yep. Thank you. Yeah, I don't think we have any questions from the audience, so you can keep going.
So to start with where data comes from and kind of where it can be stored. So just talking about data storage, and this might be back to the basics kind of thing, but I think it's nice to just take a step back and like systematically look at it in the context of training deep learning models. So we got the file system, object storage, database, data lake and warehouses. And then we have the question of like, what kind of data should be stored where, and how can we get better at this stuff and learn more? So the file system is the foundational layer, right? And the fundamental unit in this layer is a file, which can be a text file or a binary file. It's not versioned. It's easily deleted or overwritten. And really, it's just you connect the disk to your computer, you format it with some file system, and then you put files on it. This could be networked, where maybe multiple machines can access the same file system. It could be distributed, like a Hadoop file system. And it's the fastest option in terms of access to files. And it's actually a little like, it was surprising to me exactly how much faster it has got in the last couple of decades. Because my mental model is still like the spinning magnetic disk, 7,200 RPM hard drive. But SSD drives are much, much faster. So on the left, we see SATA hard drive is maybe like 250 megabit per second throughput. And then the SATA SSD is pushing 500. But the latest NVMe SSDs are pushing 3,000. So that's 3 gigabytes per second in terms of transfer rate. And their seek time, so that's if you are on one file and then you want to go to a totally different file elsewhere in the file system. On the spinning disk drive, it's very slow, right? It could be like 2 milliseconds to seek to a different location. On the SATA SSD, it's much faster, like an order of magnitude faster. But on the NVMe SSD, it's like another order of magnitude faster. So it's quite a game changer recently. What format should we store files on the local file system? I think if you have binary data like images or audio files or movies, then just store them as files like .jpeg, .mov or something. In TensorFlow, there's a thing called TF record, which has it does this thing that batches files. So if you have like 1,000 images, you might only have 10 TF record files because there's 100 images in each batch file. I think it's probably not really necessary with the fast drives that we have now. You may still want to break down your files by directory so that listing files in a directory doesn't take forever, because there's only ever like 100 files in a directory. But I'm not sure there's anything extra we really need to do to like store it as one file as a TF record or something. If you have a large tabular data corpus or text data, then let's say it's loaded up in pandas, you have some choices. So you have HDF5, which is an old and kind of stodgy file format, very powerful, very bloated, and I feel like it's declining. It's not really seeing much new development. You have Parquet, which is from the Hadoop world and the Spark world, very widespread, recommended for storing this kind of stuff. And then you have Feather, which is like up and coming right now, powered by the Apache Arrow project. And Apache Arrow is an interesting project that aims to be the kind of like lingua franca of this type of data, right? Like tabular data. So it's a column-oriented data store that's supposed to be able to speak different languages, right? So you can access it with Feather and Python. You can access it with, Databricks or something. You can access it with all these different languages and frameworks. And it's memory mapped. So that means it's very fast. Even if it's a large data set, it like gets efficiently loaded into memory. And so you can do searches and joins and stuff on it very efficiently. And if you're using TensorFlow or PyTorch, there's native data set classes and interfaces that are worth using. So object storage is kind of one level up, and that's, you can think of it as an API over the file system. So you got get, put, delete files, and you don't actually know where they're stored, but you don't need to know because like you don't really think of it as a file, you think of it as an object. And these are usually binary, but also log files and text files can be stored as objects as well. The interesting thing about making it an API is that you can build in versioning and like redundancy and other things into the API service. And so when you store a file, instead of overwriting the file, it actually just automatically maybe makes a new version, right? Or when you store a file and you want to be sure that you'll never lose it, you can crank up the redundancy setting. S3 is the canonical example of this, right? But all the cloud providers have their own version. And there's an open source project called Ceph if you want to install it on local. And it's not as fast as just writing straight up files to the file system, but it's fast enough, especially within the cloud, right? So if you have Amazon EC2 and you're loading a lot of S3 files, that's really fast. In fact, it's so fast that this is from Databricks. They recommend using S3 over setting up their own or your own HDFS setup, for example. There are databases which, hold on. This dog just keeps bringing toys and playing with them. It's kind of cute. Right, the database is persistent and fast storage and retrieval of structured data. And if you've ever heard like OLTP, that kind of refers to this, online transaction processing. And I think the mental model to have is like everything is actually in RAM, and that's why it's really fast. But the software ensures that everything also gets logged so that it never gets lost. You don't store images or audio in it. You store references to, for example, S3 objects in it. Postgres is great, usually the right choice. Supports unstructured JSON. SQLite is often used for small projects. And then NoSQL is something we've all heard, from the big data days. But I think today we should just mostly avoid it because Postgres has that unstructured JSON ability, and it also has the relational ability, and it has much better, ACID properties, like it's more consistent and so on. Except Redis is like super useful if you just need a simple like persistent dictionary that multiple machines can access. Data warehouse is this idea of aggregating data for analysis. And this is also called OLAP, online analytical processing. And Ben talked about ETL, extract, transform, load. So that's the idea that you have multiple data sources from which you extract data, transform them into some common format, and then kind of load them into the warehouse. A warehouse being something like BigQuery or Snowflake or Amazon Redshift. And most of these solutions use SQL as the interface to the data. So for analyzing the data, SQL is the language that they use. But some of the solutions, for example, Databricks, use data frames. And Pandas, which I'm sure we've all used, is the main data frame provider in the Python ecosystem. And there's, of course, like the R's data frames and stuff like that, and the Databricks data frame in the Scala world. The advice that we give to deep learning practitioners is to really become fluent in both, because we're going to be using data frames in Python. There's just no way around it. But also, it seems limiting to not be able to use SQL because that is the native language for this kind of analysis. And that is the only language that a lot of these solutions expose. So we should just be able to write both. And I think it's worth, taking a side project or two to get fluent. The idea of a data lake is that you kind of flip the ETL to ELT. So instead of extracting, transforming into a common schema, and then loading into the warehouse, you extract from different sources like your database, your logs, and what have you. And then you load it into the data lake, and then later you transform it for some analytical need. So the lake is like an unstructured aggregation of data from multiple sources. And that's really what people have been doing more than warehouses recently. But they're also converging, right? So like, for example, the Databricks platform is now calling itself a lake house, which is something where you can both store unstructured data and run analytical queries on it as if it were structured. And you can store both unstructured and structured data in the same place. And you can apply maybe even some machine learning to it. So that's really the trend. For now, I think if you have binary data, store it as objects like on S3. If you have metadata about it, like what's the label of this particular image, store it in a database because you might be querying it or changing it, right? And then if you have the need for combining different data sources or potentially processing data that is in a format that's not like readily accessible, like logs, you extract something from logs, then set up a process through which logs end up in a data lake, and then set up a process to be able to analyze things in a data lake. And then at training time, because we're doing deep learning, we copy everything that we need down to the local file system on like an NVMe drive. And that will be the best experience for actually training on GPUs. There's a lot to the story. There's a great blog post recently from Andreessen Horowitz called The Emerging Architectures for Modern Data Infrastructure that break it all down a little bit more. And there's a great book called Designing Data Intensive Applications that if you really, if you're truly interested and like are on the path to becoming a data engineer, I think this is a must read, but it does delve in pretty deep into like some of these ideas. What do you guys think?
Okay, Sergey, so we've got a couple of questions from the audience. So there's two that are related. So you mentioned that public available data will not give you an edge. Is that because the reason is that someone else can use the same data and basically now you have like no competitive advantage? Is that is that the point?
Yeah, so exactly. Yeah, like if you're trying to do a startup for, let's say in healthcare, for radiology type of data, right? So you predict some cancer or something from radiological images, but you've only trained on like publicly accessible radiological image data set, then someone else can come along, train the exact same model or a better model on the same data and basically be competing with you. But if you have an exclusive contract with some huge radiology lab and you have millions of images that no one else has, then even if they have a better model, they may not be able to compete with you until they find their own data source.
Okay, and related question from the same person. I think we know the answer, but I'm gonna ask it. So where do you place like the importance between having proprietary data and using a more advanced technique to train the model?
Well, I think it's like one of those like bell curve memes where if the model is like sufficiently advanced, like GPT-3, then you can use public data and you still have a competitive advantage because no one else can train a model that advanced, right? But if the model is not that much more advanced, it's just like slightly more advanced than what's out there, then I think it's much better to have proprietary data because yeah, it's like the model doesn't give you that much of an edge compared to data. But okay. It's an interesting question.
And another question is, so Linux file systems usually have issue with a large amount, like number of files. Do you know any solutions to work around the problem?
Yeah, so TF record or something like that would be one solution. So you batch files together into basically, or like even tar them together, right? Where you have a fewer files, but each file has actually many other files within it. Folders to some degree will give you the same thing, but you might still have a limit on the open number of files. Those are the two things that come to mind. And if other people have suggestions, then maybe drop them in chat too.
Okay. And yeah, I have a question based kind of on my own struggles. So at some point when I was dealing with like training a model to do like essential video segmentation into different scenes, and the amount of data was very large, like it was pretty much, let's say, 10 times more than what could fit on the machine that had a GPU. So we were storing it in S3. And some of my colleagues had like suggested ideas that we never actually ended up implementing. But the basic idea is using something like TF record or write a custom data loader, let's say in PyTorch, that essentially preloads the data from S3, creates a batch out of it, feeds it into the GPU, and I don't know. It still sounds like an interesting idea to me. I'm kind of disappointed that I've never actually had time to implement it. So I'm wondering what your thoughts on that are.
Yeah, I think that's necessary if you really can fit all the data. And yeah, that makes sense. So the thing about like the data loader in PyTorch or the dataset class in TensorFlow is that they do what they do in a separate process that runs on the CPU. And so they're able to load data while the GPU is busy training on data that's already been loaded to it.
Right.
So it totally could work, yeah, for them to download something from S3, process it, load it, while the GPU is like plugging away. So it could work, yeah.
Right. Yeah, I guess the challenge there would be to figure out kind of the timing so that you preload the batch, you download the batch right in time for when GPU releases it.
Well, that should be automatically handled by PyTorch or TensorFlow. Or not necessarily automatically handled, but it should be possible.
Okay.
Like that is the goal of what that separation.
Yeah, hopefully someday I'll get to that. And so from
exciting.
the audience, we have a person who just seconds your recommendation on the Martin Kleppmann's book.
Cool.
So, yeah, I think it's generally considered like a data engineering Bible kind of thing.
Yeah.
Yeah. Right. Yeah, that's no more questions from the audience.
Okay. So when you have your data, you're going from a data lake to something that's ready to be trained on, or maybe you're going from raw data into something that can be loaded into a data warehouse. That refers to, or that process is often called workflow or processing. And that was the subject of the previous talk, specifically using Luigi and Airflow for the task. I'll just breeze through this part, but I'll start with a motivational example. So let's say we train we've run some kind of website where we want to predict the popularity of photos that people upload. And we don't have to train it. It doesn't have to be like immediately available, but we train it on a regular schedule. So maybe every night. So for each photo, in order to train this predictor, we have to have some metadata about the photo, like when was it posted, what's the title, where was it taken, and so on. Then maybe something about the user who uploaded it, and then the outputs of some subject or style classifiers that ran on the photo. So the photo itself is in S3, right? But metadata about it is in our database. Maybe there's something about the user that's actually not in the database, but we have to compute from logs. And then to get the output of the photo classifiers, we actually have to run the classifiers on the photo. And so we have all these tasks where we can't start training the classifier, the predictor of the popularity, until these tasks are completed. So we have a DAG of tasks. And what we'd like is that it's a smart way to process the tasks, that some of the tasks are maybe programs or database access results. The work might be spread out over multiple machines, not just on one machine. And we're not the only ones training our predictor. There's other teams at our company that are training their own stuff, but we're all using the same machines and accessing the same files. So it's like many of these things are executing at once. So in the days of big data, the answer was Hadoop, and that was replaced by Spark. And the idea is like you're able to run MapReduce jobs on commodity hardware and restart jobs if they fail, distribute files over the file system. Spark also caches things in memory so that it's like even faster than Hadoop. Like that's not often used in Python world, I think. In Python world, we have Luigi and Airflow. So I'm not going to talk that much about that. Apache Beam is something that TensorFlow recommends for example, the Colossal Clean Corpus, which is this 7 terabyte natural language corpus that their model called T5 was trained on. So for some reason, they don't give you the pre-processed version of this, but they give you like the raw version of the crawl, and then they give you scripts to turn it into trainable data yourself. But the scripts are using Apache Beam, and you can run them on Google Cloud Dataflow. So in this case, Beam is like Airflow, and then Dataflow is like the worker queue. Prefect is something that some people use instead of Airflow. Roughly the same idea, you know, define tasks in Python, define the DAG, and so on, but could be nice to look at. dbt is an interesting idea where basically everything happens in SQL. So you're able to define not only analytical queries, but also transformations using SQL. So maybe not that useful to us as like, you know, Python first developers, but if you have people at your company that are fluent in SQL, but maybe are limited by the availability of data engineering to like transform data for them, this could be a nice thing to look at, dbt. And then Dagster is, I think, an up-and-coming orchestrator that stitches together like a lot of these tools into something that executes a DAG very nicely. So yeah, just breezed over that. One more thing, I'd like to jump over to the deployment part because it kind of straddles the gap between data and deployment, is this idea of a feature store. So the feature store idea was introduced by the Uber team a couple of years ago when they described their machine learning platform called Michelangelo. And the basic idea is that they have an offline process where, let's say they're trying to predict how to do surge pricing, like a model that predicts pricing for a given ride. So they have terabytes of historical ride information. It's all dumped into a data lake. And in order to prep it for training, they have some kind of maybe Spark or SQL scripts and stuff that run and output features that are kind of ready to be trained on into their offline feature store, the Hive feature store. And then from that, they run a training job that takes that data, trains a model, outputs the trained model. And when it comes time for production use, now they're getting online data, right? So I'm opening up my Uber app. I want to see a price like right now, right? So the prediction has to be made now. But the thing is, my usage of the app still has to be featureized into a way that the model can understand. And so now there's an online feature store that processes my data via a stream engine, puts it in the Cassandra feature store, and then the model's able to pick it up and then give me a prediction. And then historically for evaluation, you also have, you also want to be able to batch predict. So you want to be able to predict on a lot of data points at once. And so the problem here is if there's two different feature stores and two different ways to process data, there's an increasing danger of them drifting out of sync, right? And so like the type of data your model was trained on is not going to be the type of data that your model will actually see and use. So the idea is to have a unified feature store where you have both real-time data and your offline batch data going through the same pipelines, going into the same store, and then getting served out for their different uses, either model training or batch prediction or online prediction. So Tekton was founded by engineers from Uber, and it's probably the most, it's really the only feature store that I know about commercially available. And there's an open source solution called Feast that might be worth taking a look at as well. I haven't used it. So that was a lot, but the advice I think is to try to keep things simple as much as we can. So for example, like just the Unix system has powerful parallelism, it has data streaming, and it has highly optimized tools like grep and awk and stuff like that. So there was a blog post a few years ago that like basically there was a task for counting the prevalence of some word in logs. So you have a bunch of these like PGN logs, and they built a Hadoop way to do it, like using a cluster, mapping out and reducing the results and so on. And that took 26 minutes to process. But just catting the files into a grep and then sorting them and getting the unique lines was only 70 seconds in Unix, even for a sizable data set. And so like one thing that some people don't realize is when you see a command like that with the pipes, where like one command pipes over to another command, the pipe, all the commands are actually happening in parallel, and the pipe is streaming data. So it's not that like cat has to read and write out all the files before grep starts executing. It's like cat starts outputting files, grep starts processing, and then storage starts sorting, and it all happens at the same time. That's why it's able to be fast. And these tools are very specialized and optimized. And you can optimize them even more if you're like a Unix pro. For example, xargs can run things in parallel for you. So if you can get naive parallelism just with xargs or the parallel command. So, not to say we shouldn't be using all these tools that are purpose-built for machine learning, but we probably shouldn't be using them if there's only 10 gigabytes of data that we have, and we can just use like the Unix tools.
Okay, thank you, Sergey. I don't think we have any additional questions from the audience.
Okay, I'll just keep going. So exploration, I'm not going to talk much about. There's, pandas, obviously we all know. There's a way to speed pandas up. Dask is worth taking a look. And Rapids is an interesting way to do data frame analysis on GPU. But I'm going to skip over that. I will talk about data labeling though, because that can be tricky. So I'll talk about user interfaces, sources of labor, and service companies. So when you're labeling data, there's a standard set of features, right? Different types of bounding boxes, cuboids, polygons, key points, and so on. And like the notion of classes. And the most crucial thing is actually training your annotators, which start with you, like you're the first annotator of your data. You have to introspect and like decide how you're making the decisions, and then write out the exact algorithm, right, by which you're labeling data, so that every annotator on the project agrees with how things should be. And there's multiple correct answers, right? So that's why it's very important to write it out. So for example, if an object is partially occluded, it's natural for humans to imagine the whole object and potentially label the whole object. And that might be the right thing to do, or it might not. It really depends on your labeling project. But you have to give an example of a data point like this and specify exactly how it should be labeled. And then, like, people just aren't uniformly good at data annotation. So you have to make sure to watch your annotators and ensure quality, and probably not use ones that aren't meeting your quality bar. Who are the annotators? Well, you could hire your own. You could try crowdsourcing, so like on Amazon Mechanical Turk, or you could hire a data labeling company which has their own labor force. And so there's pros and cons to either one of these approaches. The service companies, I think it makes a lot of sense to outsource to them, because data labeling is really its own thing. You know, it has its own software stack, it has its own labor force, it has its own like quality assurance practices and so on. And so like you're either going to have to figure all that out yourself, or just hire someone to do it. So I think it makes sense to hire if you can afford it. But that doesn't mean you get to just abdicate the data labeling project entirely, because you first have to label your data yourself in order to decide how it should be labeled, right? And like spend 10 times as much as feels comfortable doing this, right? And then give the data that you labeled without the labels to several different companies to ask for their sample labels, right? And then whichever one meets your accuracy bar and is cheapest, then that's the one I would go with. Figure 8 is like the biggest player probably. Scale.ai is definitely the dominant, like more recent company doing data labeling. And there's a lot of other ones like Labelbox or Supervisely and many others. So these are the full service data labeling companies. And some of them also provide just the software, so you can bring your own labor or just use it yourself. There's, in fact, even open source software, which I recommend, called Label Studio. Very flexible. You kind of define your labeling interface using this HTML-like interface. There is an enterprise edition for managed hosting. It's also written in a way that lets you plug in different backends. Like maybe you might have a machine learning backend that suggests things to label, like in an active learning type thing, or potentially pre-labels data such that the annotator just corrects labels instead of starting from scratch. And they give you an interface for just reviewing your data, which is very useful. Speaking of reviewing your data, Scale Nucleus is a product that I'm not sure of the pricing. It might even be free. I'm not sure. But they give you a interface for reviewing your annotations and also your model predictions, such that you can identify cases where your model made a misprediction or is like most confidently wrong or something like that. And then you can mark things off to get labeled. And it's just useful to like take a look at your data. So this is an example of their interface on the Berkeley Deep Drive dataset for self-driving. So Aquarium is a startup that has like similar software, but potentially even better, because they also support sensor fusion. So like in the top right corner, you see this like LiDAR type of data. And they also focus on like finding data points that haven't been labeled yet, but that are similar to incorrectly labeled points by your model. And so that lets you select the best data points to be labeled to improve your model performance. This is a startup by some engineers who used to work on Cruise Automation, the self-driving car company. And then the last idea I want to introduce is the idea of weak supervision. So Snorkel is the project that kind of introduced this idea. It's both an open source project and now a commercial platform that's kind of in beta right now. But the basic idea is like, let's say you're trying to label reviews for sentiment. Like, is it a positive review or negative review? And if the review contains the word fantastic, then almost certainly it's a positive review. So you might write a quick function that says, if fantastic in the text, then positive. And you write a lot of these kind of heuristic functions, and potentially even some poorly performing models. So maybe you download an off-the-shelf model of sentiment analysis and you run it on your data, and you add that to the mix too. So Snorkel is going to combine all these sources of heuristic and other predictions and kind of find the data points that like require good labels. So in conclusion, if you can afford it, have a full service company, like provide the labor and the software. Of course, you have to label the ground truth yourself, the gold standard. If you can't afford it, then at least try to use existing software instead of like making your own. And crowdsourcing, I think, just is very difficult to make work. So at least try to hire your own like part-time annotators instead of trying to make Mechanical Turk or something like that work. What are people's thoughts about this area?
No questions. I think we're good.
Okay. So lastly, let's quickly talk about versioning. So data versioning, I think of as like different levels. So the first level, which we should not do, is just not versioning. So we just have our data, it like lives on the file system, or it lives on S3 or in our database, or both. And we just train a model, and then at some point we deploy the model. But the problem is when we deploy the model, we definitely version the code, right? That's just like software engineering 101. But the problem is that the machine learning model is partly code and partly data. And so the code was versioned, but the data was not versioned, which means that the deployed model is also not versioned, which means that we'll eventually have some kind of problem where like performance dropped and we want to revert back to an old version, but we're unable to get back to that old version because we can't retrain it because the data just kind of moved on. We can't retrain it using the old data. So a simple solution is just, okay, let's take all the data we're training on and just store it as like a snapshot so that if it changes later, at least we'll have the snapshot. And, if your data is not that large and you can afford to store a snapshot, then this actually could work, but it's just super hacky. And like, wouldn't it be nice if we could just like we say, git add and git commit, wouldn't it be nice if we could do that to data as well? So here we get to level 2. Where we basically try to represent data as code. So for example, if you have an image data set, then the images themselves live in S3, and we assume the binary data, like the pixel data, is not changing, and each image has a unique ID. And then in our code base, we can store, for example, a JSON file of that unique image ID and its label. And so this JSON might be like a large file. Maybe it's a gigabyte, file. But with this thing called Git LFS, which is Git large file storage, we can store it alongside our data just using Git. And it actually works pretty well. And it's not a problem at all with fast internet connections. And so then what Git LFS does is it basically takes us like an MD5 hash of that JSON file, and it stores that, and it uploads the JSON file to S3 behind the scenes for us. And so that versions the file, basically. So it versions our data. And then level 3 is potentially a good idea, potentially not a good idea, but these are specialized solutions for versioning data. So could totally be like super helpful to your project, or it could be overkill and it's just not clear until you know more about your project. But you should take a look at DVC, Pachyderm, Someone made a diagram here. So there's DVC, Git LFS, Pachyderm, LakeFS, Delta Lake. So DVC is really interesting. So you basically you have Git and you have DVC. So you can Git add code files and DVC add data files. And it also, you can DVC run to produce files that are, you can kind of keep track of the provenance of models and so on by just saying like this file came from this data file and this data file and this script, and then it remembers it all. Dolt is an interesting thing specifically for SQL. So you can dump your database into a Dolt file, and then you can use SQL to like quickly look at it. But more importantly, you can resolve merge conflicts using Dolt. So it's like if you represent your labels in a database format and you have multiple people working on it, maybe they add labels, differently, but then you can resolve it with Dolt. And I guess I'll just keep on going. Like one last thing that is becoming increasingly important is like preserving privacy when it comes to data. And this is an area of research. I'm not sure there's a really good, production software to recommend yet. But just to introduce some ideas, there's the idea of federated learning, which is that we're training a global model on our own server, but from data that we actually don't have on our server. So the data lives on local servers, and we send a copy of our model over to the local servers. They train that model using the data they have access to, and they send us something, and then we sync it together across all the different sources of data. And then we send the updated model and so on. So for example, in healthcare, this could be very necessary. There's a research area called differential privacy, which is studying how we can aggregate data such that we can train on the aggregated data without ever revealing the individual data points that made up the aggregate. And then another topic that I feel like doesn't quite work just yet is learning on encrypted data. There is a great resource for this kind of stuff. It's called OpenMind, and they actually have a series of courses that some are already published and some are in development on these topics. I think this will be a big topic in the near future. So that's it from me. Thanks for hosting. I hope you have questions.
Yeah, there are a couple of questions that came in. So first one is, so a few terms that you mentioned. So data versioning, and then there's data provenance, and then there's also a question about data lineage. Are they related? Are they all the same thing? What are the differences?
Well, data versioning is not necessarily data lineage and data provenance, I think, are probably two different words for the same idea. And the idea is that you should be able to trace how a given trained model file or some process data file, how it came to exist from the raw data file constituents. So maybe there's a raw log file, and then it was processed in this one way, and then it was processed in this other way, and then a model was trained on it. And so then we can ask, what is the data lineage of this model? And we should be able to trace it all the way back. But data versioning is going to have to be a part of that solution. But you can also just do data versioning without the full data lineage, because you can just say, like, oh, I trained on this data, here's the version snapshot. But you don't necessarily know where that data came from. So maybe it just doesn't go all the way, but data versioning is just like code versioning. Okay.
Understood. One more question. Any experience or impressions with Git Annex or data-led versioning? Got to be honest, I've never heard of data-led.
No experiences. I haven't heard of it, so I'll look into it.
Okay. Interesting. Then I think we are done with questions.
Excellent.
Okay. I think Maria and Ben are going to join us in the stream just for wrap-ups. Okay. Okay, so thank you both, Sergey and Ben, for spending this time with us and preparing for the presentations. It was a great learning experience. I definitely learned quite a few things.
Awesome.
Yeah,
Thank you
my
guys.
pleasure. Thanks for hosting.
Yeah.
And yeah, feel free to contact me. Like Twitter is my full name, Sergey Karayev, or yeah, just search for me.
Yeah, I'd like to plus one what Alex said. Both of you had amazing presentations. It was a joy to listen. Very interesting, a lot of information too. So excellent presentations. Very informative, but also very enjoyable to watch and listen. I also wanted to say thank you to everybody who joined the meetup and stayed all the way to the end, and for their questions, for their um, missing the word. It happens sometimes in the evening. So yeah, we were happy to see folks joining and to see you both presenting at our meetup, and we hope to meet you someday in person.
Yeah.
Right. Have a good weekend, everyone.
Yep.
Gonna
Bye.
end the stream now. Okay, bye.
Bye.
Right.
See y'all.